Here's an example of a system with three unknowns. We need to find out what is the value of x, the value of y, and the value of z. And here is our system of three equations, equation 1, equation 2, and equation 3. And we're going to use elimination method. So I'm going to start off with two equations. So I'm going to start off with equation 2 and equation 3. So I'm going to rewrite equation 2 and 3. So I have 2x plus 4y minus z equals 7. And then 2x minus 4y plus 2z equals negative 6. I'm going to try and eliminate one of those variables. So I'm going to add the two equations together. 2x plus 2x is 4x. What happens is this 4y minus 4y cancels out, and then negative 2z plus z is z, and then 7 plus negative 6 is 1. So I have the equation 4x plus z equals 1. I'm going to work with that later. Now let's go back up to our original system. Now I'm going to work with equation 1 and 2 and see if I can get the same variable to cancel out. So I'm going to work with equation 1 and equation 2. So I have x plus 4y plus z equals 0. There's equation 1. And then equation 2 is 4x plus 4y minus z equals 7. Now, if we add these together as they are, the y will not cancel out. So I'm going to change this equation to multiplying it by negative 1. So I get negative x, negative 4y, negative z equals 0. And then I still have that second equation left alone. 2x plus 4y minus z equals 7. Now let's go ahead and add these two equations together. So negative x plus 2x is x. Negative 4y plus 4y, again that canceled, that's what we wanted. And then negative z plus negative z is negative 2z. And then 0 plus 7 is 7. So I'll just rewrite this. X minus 2z equals 7. Now we're going to work with this equation here and that equation there. And we're going to set up a new system with just two variables. So here's my first equation in the red. 4x plus z equals 1. And here's my second equation in the blue. X minus 2z equals 7. Now our goal is to eliminate another variable in this system. So either you can choose to eliminate the x variable or the z variable. So I'm going to try and eliminate the z variable. Actually, let's eliminate the x variable. So I'm going to multiply this equation by 4. So I have negative 4x plus 8z equals negative 28. And then the top equation will just stay as it is. So 4x plus z equals 1. Now let's add those together. And what happens is the x's cancel out, because 4x minus 4x is 0. And then 8z plus 1z is 9z. And then 1 minus 28 is negative 27. Now we're down to one variable to solve for z. So divide both sides by 9. Negative 27 divided by 9 is negative 3. We found our first variable. Now go back up either into this red or blue equation that I've circled. I'm just going to choose the red one right here. 4x plus z equals 1. 4x plus z equals 1. And now we're going to substitute negative 3 in for z. So we get 4x, add 3 to both sides. 4x equals 1 plus 3 is 4. And then divide both sides by 4. So 4 divided by 4, x equals 1. We now have our second variable solved. We have one more to go. We have the y variable. So now we go back up to our system. I'm going to just choose the top equation. And you can choose any of these equations, it doesn't matter. So we have x plus 4y plus z. X plus 4y plus z equals 0. Now we're going to substitute negative 3 in for z and 1 in for x. So x replaces with 1, y is still left alone, and z is negative 3. And we have this variable y to solve for. So 4y, 1 minus 3. 1 minus 3 is negative 2. And then add 2 to both sides. And then divide both sides by 4. So y equals 1/2. So then our final answer, x equals, y equals, z equals. Y is 1/2, we just found it. Back up here, x was 1, and z is negative 3.